Okay, so describe fully the transformation which matches curve A onto curve B. This is a bit where you're going to need your data sheet. And your data sheet shows you that you have curve A, which is here, you have curve B, which is here, and it tells you it is a reflection of curve A in the line y equals x. So that is purely and simply a can you read your data sheet question. So for part AI, sketch and label the graph of y equals 10 ln x. So if we go into our graph settings and delete the last one, we've got y equals 10 ln x, and the grid that we've been given on our data sheet is from 0 up to 64 and 0 up to 64 in the y direction. So we have our initial sketch of it. Things that are useful, we'll be finding out what that root there is. So if we go gsolve root, that's coming in at 1. And if we find out what it is when x equals 64, then that gives us the other bit of information. So that's coming in at 41.5. So we have something that is going to look 40 is about there. So we're looking at something that goes kind of like that. So where it crosses our axes, this is at 1 and this is at 41.6. So how do we rearrange this to find the inverse function? We start off with y equals 10 ln x. So for the inverse function, we need to swap our x and y. So we end up with 10 ln y. So first off, we can divide both sides by 10, and that will give us x over 10 is ln y. And then if we do this to the power of e, we've got e to the power of x over 10 equals y. And if we just reorder it so it looks a little bit more normal, we've then got our inverse. We're asked to sketch and label this graph. So this graph, the one that we've already drawn, is y equals 10 ln x. Now our inverse should cross at 41.6. It should start at 1. The other bit that we're going to have to put in is where the two things intersect. So if we come out of that and go e, and that is x divided by 10, and then we should draw that. So it's got 2 points of intersection, so we can go gsolve intersect, and the first one is at 1.1, so almost immediately, which is what we'd expect, and the second one is at 35.35 or 35.7. So our other one about there. So that point there is 35.7, 35.7. That point of intersection is at 1.1. and this graph okay, don't have rubber. So this graph was y equals e to the x over 10. Rub out this bit so that it doesn't look messy. I apparently don't have a rubber at the moment, so that's not a thing that's going to happen. Okay, so for B part 1, we've got this curve. We are still working on the same grid. So if we come out of there, we are going to delete both of those. And we're looking for our new equation. So our new equation is x minus 32, not 2 minuses, just 1, squared divided by 16. So if you look at this curve, its line of symmetry is going to be from its minimum point. So if we do G solve min, we've got an x value of 32. So its line of reflection is going to be at x equals 32. So a line that goes up here. So for B part 1, line of reflection is x equals 32. And then we're asked to rearrange the equation to find the inverse function. So B part 2, if we swap the x and y over, divided by 16, then we've got to think about rearranging it so that we've got a y equals equation. So if we times both sides by 16, we end up with 16x y minus 32 squared. We're then going to need to square root both sides, so we end up with 16x y minus 32. We could divide this or square root the 16, so we end up with 4 square root of x, but we don't have to. We can then move this 32 to the other side, so we end up with square root of 16x plus 32 is y. Now, because it's a square root, we need both of the answers. So if we then rearrange it to equal y, we've got 32 plus and minus the square root of 16x.